Configure and modify a standard IPv4 access list. Addressing table R1 with 3 interfaces, R1 3 interfaces, Edge router 3 interfaces, Edge router 3 interfaces, R3 router 3 interfaces, 3 interfaces on R3 router, 4 switches, 4 end devices, 4 PCs, 4 PCs. Verify connectivity from PCA, ping, PCC, and PCD. From PCA, ping, PCC, and PCD. PCA, desktop, ping, okay, PCC 30.3, PCD 40.3. 192.168.30.3, okay, from PCA, ping, PCC, success. Now PCD 40.3 from PCA, ping, PCD, success. The answer here is yes. Were your pings successful? Yes. From R1, ping, PCC, and PCD. From R1, ping, PCC, and PCD. Go to R1, command line interface, enter, enable ping 192.168.30.3, success, 40.3, success. Were your ping successful? Yes. From PCC, ping, PCA, and PCB. From PCC, ping, PCA, and PCB. Go to PCC, desktop, command prompt, ping 192.168. PCA IP address 10.3, PCB IP address 20.3. 10.3, success. From PCC to PCA. From PCC to PCA, success. And from PCC to PCB, 20.3. Okay, from PCC to PCB, success. So the answer here is yes. From R3, ping, PCA, and PCB. From R3, ping, PCA, and PCB. Go to R3, command line interface. Enter, enable ping 192.168.10.3, success, 20.3, success. The answer is yes. Can all of the PCs ping the server 209.165.200.254? For example, from PCB to the server, ping from PCB ping 209.165.200.254. Okay, be careful. 209.165.200.254. Enter. Success. From PCD, for example, ping the server. Desktop, command prompt, ping 209.165.200.254. Success. The answer here is yes. Configure and verify a standard numbered and named access list. Configure a numbered standard access list. A standard access list filters traffic based on the source IP address only. A typical best practice for a standard access list is to configure and apply the access list as close to the destination as possible. For the first access list in this activity, create a standard numbered access list. Okay, a standard numbered access list, use number 1, Remember, the range for standard access list is from 1 to 99 and from 1300 to 1999. Okay, that allows traffic from all hosts on the 192.168.10.0 network and all hosts from the 192.168.20.0 network. Okay, and permit 192.168.10.0 network and permit 192.168.20.0 network. And this is the inverse mask or wildcard mask. Okay, this is the wildcard for 24. Okay, for 24. To access all hosts on the 192.168.30.0 network. Okay, and where is this network? 192.168.30.0. Is this subnet 30.0 network is placed on gigabit 000 on R3. Okay. This is gigabit 00 on R3. So this is the destination. This is 192.168.30.0.24 prefix. Okay, is this network. Okay, this is the destination. And where are the sources? Sources are 10.0 and 20.0. 10.0 and 20.0. Sources are 10 subnet and 20 subnet. Placed on R1, gigabit 000 and gigabit 001. Gigabit 000 and gigabit 001. Okay, these are the subnets, the source 192.168.10.0.24 and 192.168.20.0.24. Okay, this is the source and this is the destination. Okay, this is the source. This is the another source. And the destination here. Okay, this is the source and this is the destination. A typical best practice for standard access list is to configure and apply the access list as close to the destination as possible. So that's why you can configure on R3, because it's close to the destination. And look at the arrows. You can configure on serial interface on R3 incoming traffic, or on gigabit interface on R3 outgoing traffic. In this case, you will configure on gigabit 000 on gigabit 000 outgoing traffic on R3. Okay, so that's why you need to configure this on R3 router. On gigabit interface outgoing traffic, gigabit interface outgoing traffic. The security policy also states that an explicit deny any access control entry, also referred to as access control list statement, should be present at the end of the all access list. Okay, deny any at the end. Okay, there is an implicit deny any at the end of an access list, but in this case you will use an explicit deny any. Okay, go to R3, enter enable configure terminal. Access list standard number 1. Remark is only a label, only a description. Allow R1 lang case sensitive for the score langs access. Enter. And permit 192.168.10.24. This is the wildcard mask for 24. Okay, now for 20. And finally, deny any, explicit deny any. And go to interface gigabit 000 IP access group 1 out. Interface gigabit 000 IP access dash group 1 out. Outgoing traffic, access list 1, this access list. Very good. Okay, what wildcard mask would you use to allow all hosts on the 192.168.10.24 network to access 192.168.30.0.24 network? And the answer is the wildcard mask for the prefix 24 is 0000255. 0000255. Following Cisco's recommended best practices, on which router would you place this access list? On R3. Okay, R3. On which interface would you place this access list? In what direction would you apply it? You can apply on serial interface or also on gigabit interface, but close to the destination is gigabit interface. The answer here is gigabit 000. Gigabit 000. The access list should be applied going out. Okay, gigabit 000 outgoing traffic on R3. Okay, if you will apply the access list on serial interface, you will also block the access to this another LAN. Not only this LAN, also you will block the access to this another LAN. Okay. Show commands to verify. Go to R3 and show access list. Okay. Access list 1, the 3 entries. Also, you can use show IP access list. Okay, the same result. Show IP interface gigabit 000. Okay, in outgoing access list is number 1. And show running config. Okay, on gigabit 000 IP access group 1 space, and this is the access list. To see the access list number 1 in its entirety with all access control entries, which command would you use? Okay, you will use show access list command. Show access list. What command would you use to see where the access list was applied and in what direction? Show IP interface gigabit 000 or show running config, or also show IP interface. Show all interfaces and go to gigabit 00 section, and you can see the placement of the access list. That's the access list from PCA command prompt ping PCC. From PCA ping PCC. PCC IP address is 30.3. Go to PCA, ping to 30.3. Success is permitted. That is okay. Were the ping successful? Yes. From PCB, ping PCC. From PCB, ping PCC. Ping 30, ping 192.168, 30.3. Success is permitted. Ping successful, answer is yes. Okay. Should pings from PCD to PCC be successful? Okay. Ping from PCD to PCC. Ping 192.168 30.3. Destination host unreachable. Okay, this is expected because the configuration of the access control list. Okay. So the answer here is no, the pings should not be successful. Trying the ping verifies that the access list is working very well. From R1 prompt ping PCC's IP address again. Okay, from R1 ping PCC. Enter, enable ping PCC 192.168 30.3. Okay, U for unreachable. Was the ping successful? Explain. No, the pings failed. When you ping from the router, it uses the closest interface to the destination as its source address. The ping had a source address of 10.1.1.1. The access list on R3 only allows the 192.168.10.0 and the 192.168.20 networks access. Okay, when you ping from R1 to PCC, the source address of R1 is the serial 010 on R1. This is the source, serial 010 on R1. Serial 010 on R1. The source is 10.1.1.1. This is the source. And the destination is PCC. But R3 only permits this network and this another network. 10.0 network and 20.0 network. 10.1.1.1 is not permitted. So that's why the ping is unreachable. Show access list 1. Okay, go to R3. Show access list, but specify access list number 1. And you can see 4 matches for this entry, another 4 matches for this another entry, and for the 9th entry, 9 matches. Okay, 4 pings successful to 10.0, 4 pings successful to 20.0, and the 9 blocks 9 packets or 9 pings. Configure and name it a standard access list. create a named standard access list that conforms the following policy. Allow traffic from all hosts on 192.168.40.0.24 network access to allow hosts on 192.168.10.0.24 network. Okay, the source is 40.0 and the destination is 10.0. Okay, 40.0 is placed on PCD. This is the subnet on R3 gigabit 001, R3 gigabit 001, and this is 40 network, 192.168.40.0.24 network. Okay, this is the source and this is the destination. Also, only allow host PC access to 192.168.10.0 network. Also, PCC can access 192.168.10.0 network. So this is the another source and this is the destination. Okay, remember it's a standard access list. A standard access list should be placed close to the destination. Okay, permit host 192.168.30.3. Okay, permit PCC 192.168.30.3 is PCC. So that's why you will use the host keyword. Only permit the host, not the subnet, only this host. Host 30.3. Okay, allow traffic from host 192.168.40.0. Okay, so that's why you will use permit 192.168.40.0 and wildcard mask for 24 prefix. Okay, this is the source. This is the another source. And this is the destination here. Okay, this is one source. This is the another source. The first source is 192.168.40.0 subnet, and another source is PCC host. And this is the destination, this subnet, 192.168.10.0. Okay, and place the access list close to the destination. So you can use R1, close to the destination. And on R1, you can use gigabit interface outgoing traffic to place the access list close to the destination. Serial interface, you can also configure the access list on serial interface, but it's not close to the destination, it's not so close. And also, if you will configure the access list on serial interface, you will also block access to this another LAN, not only to this LAN, also to this another LAN. So that's why it's better to use gigabit interface outgoing traffic. Okay, interface gigabit 000, interface gigabit 000 out. Okay, name it a standard access list, IP access list, a standard, because it's a standard access list, and name it. Use a name, do not use a number. Permit host PCC, permit subnet 40.0, and place interface gigabit 00 out. On R1 gigabit 00 out. R1. Okay, enter, enable, configure terminal, IP access dash list, standard, branch dash office dash policy. Okay, case sensitive to get the score to get the points underscore. Enter. Permit host PCC. Permit host 192.168.30.3. 30.3. This is PCC. Permit 192.168.40.0 wildcard mask. Okay, permit the subnet 40.0 and okay, but at the end of these two lines there is an implicit deny any. Remember that implicit deny any at the end of these two lines, and place on gigabit 000 outgoing traffic. Configure terminal in configure terminal interface gigabit 000 IP access dash group and use this name, branch office policy, the same name, branch office policy. Okay, is dash. Be careful. Enter. Okay, in complete command, I forgot the direction outgoing traffic. Very good. Exit. Following Cisco's recommended best practices, on which router would you place this access list? R1, close to the destination. On which interface would you place this access list and in what direction? Gigabit 00 out on R1. Okay, gigabit 000, the access list should be applied going out. If you will apply this access list on serial interface on R1, you will block access to 20.0 network and 10.0 network. Look at the first access control entry in the access list. This is the first access control entry. What is another way to write this? Okay, another way to write this is the following. Permit 192.168.30.3. Okay, and the wildcard is this 0000. Okay. Okay, this is, for example, this is the prefix. This is the subnet mask, and this is the wildcard mask. For example, for 24 prefix, the subnet mask is this 255, 255, 255.0. In the wildcard is the inverse, this. But for host, the wildcard is 32, and the subnet mask is this 255, and obviously the inverse is 000. So that's why I'm using this. Another example for 30, the subnet mask is this, and the inverse is this. 252 plus 3 is 255. 255 plus 0, 255. 0 plus 255, 255. Very good. Verify access list, go to R1 and show access dash list. This is the access list, the name, and the entries. Is there any difference between this access list on R1 and the access list on R3? Okay, go to R3, show the access list, the access list, go to R1, this is the access list. Okay, the answer is there is no line 30 with deny any on R1. There is no line 30 with deny any on R1. It is implied if the explicit deny any access control entry is present, it can be logged. And the number of matches for the access control entry condition can be viewed with show access list. Okay, on deny any, you can see the matches. For implicit deny any, you cannot see matches. Okay, show IP interface gigabit 000 on R1. Show IP interface gigabit 000. And you can see here outgoing access list branch office policy. From command prompt of PCC ping IP address of PCA. From PCC ping to PCA. Go to PCC. IP address of PCA is 10.3. Okay, 10.3. Success. Very good. Is permitted. Were the pings successful? Yes. Test the access control entry to ensure that only PCC host is allowed to access 192.168.10.0.24 network. You must do an extended ping and use the gigabit 00 address on R3 as your source ping PCA's IP address. Okay, from R3 gigabit 000, this is the source gigabit 000 on R3 ping PCA. Go to R3, enter, enable, ping, enter, protocol IP, enter, target IP address, PCA, this is the target, 192.168.10.3. 5, enter, enter, extended command, yes. Source interface, okay, the source is gigabit 000 on R3, gigabit 000 on R3, 30.1, 192.168, 30.1, enter. Okay, enter, 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 enter. Destination host unreachable. So this is expected because only PCC is permitted and not the subnet, only PCC. Were the ping successful? No. Ping from 192.168.40.0 network to 192.168.10.0 network. From PCD ping PCA. From PCD ping PCA. Okay, 10.3. Success, very good. Were the ping successful? Yes. Now modify a standard access list. Attempt to ping the server 209.165.200.254 from PCA. From PCA, ping the server. Ping 209.165.200.254. Enter. Notice that the ping is not successful. Okay, ping fails. The access control list on R1 is blocking internet traffic from returning to PCA. Okay, the ping from PCA to server, the echo ping can reach the server, but the echo replay from the server to PCA is not permitted because an access list is configured on R1. Another way to see this is on simulation mode. Okay, show or none. Edit filters, only use ICMP. Only use ICMP traffic here. Go to PCA, ping to web server 209.165.200.254, enter, and play. And increase the speed. Okay, the ping can reach the server, but the echo replay is not permitted on R1. Okay, you can see again the echo ping can reach the server, but the replay is not permitted because an access list is configured on R1. Okay, real time, very good. Okay, management has decided that traffic that is returning from 209.165.200 to 24.27 network should be allowed full access to the 192.168.10.0.24 network. Management also wants access lists on all routers to follow consistent rules and deny any access control entry should be placed at the end of all access lists. You must modify the branch office policy access list. On R1, you will modify this access list. You need to permit the ping to internet also add an entry at the end, deny any, explicit deny any at the end. You will add 2 additional lines to this access list. There are 2 ways you could do this. Option 1, issue a no IP access list standard branch office policy command in global configuration mode. This would remove the access list from the router. When the access list is gone, you could retype the whole access list. Option 2, you can modify access control list in place by adding or deleting specific lines within the access list itself. This can come in handy, especially with access lists that are long. The retyping of the whole access list or cutting and pasting can easily lead to errors. Modifying specific lines within the access control list is easily accomplished. For this activity, use option 2. Recommended. Modify. First, show the access list. Okay, on R1, show access dash list. Okay, this is the name and 2 entries. Okay, first enter the access list. Configure terminal IP access dash list is standard branch office policy. Okay, first enter the access list configuration mode. Standard access list configuration mode. A standard named access list configuration mode. Very good. Now, you have 2 lines, 10 and 20. If you will add new lines at the end, you will use higher numbers than 10 and 20. Okay, so that's why you will use 30 and 40. Okay, add 30, permit 209.165, 200, 224, and wildcard for, okay, remember this is the this subnet is the subnet on each router, and the subnet is here. Okay, 209.165, 200, 224, 209.165, 200, 224, and the prefix is 27. If the prefix is 27, the subnet mask is 224. And obviously the wildcard will be 31 because 224 plus 31 is 255. Okay, 31. Very good. Enter. And at the end, explicit deny any for the line, deny any. And now repeat show access list, and you will see 4 entries. Very good. Now, do you have to apply the branch office policy to the gigabit interface on R1? Okay, go to R1, show running config. On gigabit 000, already placed. The access list is already placed on gigabit 00, on gigabit 00. So it's not necessary to configure this again. So the answer here is no. The IP access group branch office policy out command is still placed on gigabit interface. Test the access list. From PCI, ping the server. From PCI, ping the server. Ping PCI, ping to the server 209.165.200.254. Success. Were the ping successful? Yes. As you can see, standard access lists are very powerful and work quite well. Why would you ever have the need for using extended access lists? Standard access lists can only filter based on the source address. They allow or deny everything, all protocols and services. Extended access lists, while harder to write, are very good for complex networks where you may need to allow traffic for only certain layer 4 ports to have access to networks while denying others. In addition, standard access lists must be applied as close to the destination as possible. This allows unnecessary traffic to use networks bandwidth. Extended access lists can block traffic close to the source. This prevents unnecessary traffic from traveling to the destination where it is blocked. More typing is typically required when using named access lists as opposed to a numbered access list. Why would you choose a named access list over numbered? The first reason is that using named access lists gives you the ability to modify specific lines within the access list itself without retyping the entire list. Newer versions of iOS allows numbered access lists to be modified just like named access lists. Second, having a named access list is a good best practice as it helps to document the purpose of the access list with a descriptive name. Okay, 100%. Thank you very much.